this was looking at the very first example that we looked at a minute ago. So lead 1 was positive, and AVF was biphasic, and slightly more positive than negative, but we'll see exactly what it's going to be. So as we're looking at that and we're measuring, it's, maybe a box more positive than it is negative on the AVF side. So we know we're in the normal quadrant. So we've set our T on AVF because it's the most biphasic. It's pointing towards lead 1 already. And now we have to decide how to shift it. We know that it's slightly more positive than negative, but just barely. So we're going to shift it 5 degrees or so, and we'll be within 5 degrees of the actual axis. And we're going to shift that 5 degrees closer towards the positive, towards AVF, because it's positive, as opposed to away from AVF. Make sense? And that gave us our degree. Or it gave us our degree within a margin that is perfectly reasonable.
So then is this now labeled as a normal 5 degree?
Yep. Normal axis at 5 degrees.
Normal axis.
And when you put the variation like plus or minus 10 or...
Yep. And you don't have to do that because I'll do that. So we looked at this example. Lead 1 was negative, AVF was positive, so we're in the right axis. We found AVR is the biphasic lead, so we put our T on AVR and it's pointing down. AVR is more positive or more negative? More positive. So we are going to shift it towards AVR. And is it a lot more positive or a little more positive?
A lot more.
Than it is negative, I mean.
Almost double.
Really?
Wait, what did you say?
Okay,
Yeah, it's not double.
your eyes are better than mine.
It's less than one big box on the bottom and greater than one big box on the top.
Yes, if we doubled it, it would be,
Two boxes.
darn close to 15 degrees. So it's somewhere between 10 and 15 degrees. Right? So we know that it's pointing at 120 degrees, and we're going to shift it by at least 10 degrees. So we would say this is right axis deviation of 130 degrees. Okay. We looked at this example.
Do we label anything, so right axis deviation of 130 degrees and it's pathologic?
You don't have to say pathologic because the fact that it's a right axis deviation is pathologic. Unlike the left axis, which you have to determine, you have to note the difference.
But if you just put left axis deviation at negative 20 degrees.
You'd be fine.
Okay.
You'd be fine.
There's no physiological.
Normally we would say physiologic left axis deviation at 100 or at negative 20 degrees would be the whole sentence.
Okay.
So we've got a positive lead 1, we have a negative AVF, so we're looking at a left axis deviation. We have a negative lead 2, so we know that it's a pathologic left axis deviation. So we've already isolated it within 60 degrees, right, between negative 30 and negative 90 already. We look at our most biphasic lead, and we agreed previously that it's AVR, because AVR is the smallest of all the leads as well. So we have our line on AVR. And as we're looking at AVR, and we're trying to decide if we're shifting towards or away, is it more negative or more positive?
Negative.
How much more negative than positive? Quite a lot, right? Quite a lot. So we're going to shift it a good 15 to 20 degrees. Granted, if we start shifting it closer to 20 degrees, we should change our, which one was biphasic, right? So we can actually balance between lead 2 and AVR because those are the two that we went back and forth on the biphasicness, and it's pretty close. Ultimately, it's pretty close to the 15 degree mark between those two.
You're only concerned with amplitude.
And that's all, I'm only concerned with the proportion of amplitude right now. Yeah, so most appropriately, I would probably argue that this would be almost right at negative 45. Probably negative 46 or 47 would be the perfect answer to this. Because that makes AVR slightly more biphasic than lead 2 by a degree or 2. Does that make sense? Our EKGs are never going to be that clean because of all the impedance and all the other things we have to deal with, so I would never ask you to be that accurate. But if everything was perfect, that would be the most accurate answer. Make sense? Questions on axis and determining the axis on everything?
Why isn't there downward deviation in lead one then?
Why isn't there downward deviation in lead one?
If
Well,
the-
there is a little bit, but we've got depression that's happening there as well, so that repolarization is gonna muff it up a little bit too. Because there's something wrong with this patient. You've got clear ST elevation going on down here. You've got flip T waves and ST depression going on here. You've got a little bit of elevation there. You've got some reciprocal change there, so you have.
Okay,
you
so
have
if this was a
pathology.
normal patient though, they would have.
You would see a little bit of deflection there
Okay.
that you just can't see because everything is being disrupted already.
They're based on higher.
Make sense? Questions? All right, so you just did a bunch of axes on there. Now you can go back and determine physiologic and pathologic, and you actually go back and determine the actual degrees. Enjoy. One more step in our